Okay, hello everyone. Welcome to another version 15 design review. This one is about incremental objects in the compiler. So, Tom, please take it away.
Sure, yes. So I'm afraid it's me again, Stephen. So anyway, right. Now, so this is incremental object, which is a new thing. So it's like pre-built. So we had incremental function in 14.3, which you have to run the compiler. So this thing here is a little bit like that, but they're like pre-built things. And there's a bunch of different flavors. Okay.
Yep.
So this is kind of like zeroth order is one, and we can debate all the names and things. Um, I called it identity, and then you can iterate. So you give it a source, and then you go through the different values with
Keep
a
going,
with.
keep going, keep going.
Yep,
Hit it
fine,
again,
okay.
hit it again, hit it
And
again, hit it again, hit it again. Wait, wait, wait,
oh,
wait, wait. On the
this
next
one,
value, hit it again,
yeah.
hit it again.
And you get a failure when it goes
Okay.
off the end. Okay. So you could put this into confirm, for example, if you were worried about the length or something. Now, certain constructs that process iterators like table and do can, sort of swallow these in a sensible way.
And how many, which such objects? So, for example, if I did this with map, could it swallow it? If I
No,
said map,
because map means something a bit different, actually. I don't think that map should swallow it, and we'll
okay.
see why that is. But I think the things that are table, do, sum, and product, which are the things that have special behavior for
All right, let's look at
this.
permutations. Could we look at permutations?
Yeah, sure. Right. Well, can I just show you these, just show you one or two things, just to show
Yeah,
you
okay,
what,
right.
right. So it has, you can have like an input form. This is how it's different from incremental, it has like an input form and you can reconstitute that. You can also feed in like an incremental function. Now, okay, permutations, his permutations. So you give it a list and
Okay, so here's what I want you to show me. Okay, here's what I want you to show me, right? I
right,
want you to, yes, the thing you're going to do next, but I want you to type ds equals incremental, the permutations, blah, blah, blah. Yeah, that thing, take that out. Okay, now
right.
just show me that. Just hit that.
Okay.
Okay, now what's the input form of that?
Well, I haven't. It'll have an input form holding the internal state of the thing.
Let
I
me
haven't
see.
put
Let me
that
see.
up at the moment. There,
Um,
there isn't a use. There isn't anything.
well, okay, fine.
I haven't implemented that yet.
It's
But
okay. All
but
right.
it's
So,
entirely. That's just
okay,
a
so
question.
now just say, table next value, comma 10, next value of ds, comma 10.
Right.
Magnificent.
I mean, this could be bigger than
No,
10.
I understand, obviously.
Right. And right now, I made these other things so you can nest these incremental functions. So this is putting it into like uses take syntax.
Okay, to comma minus 20. Show me minus 20 at the end there.
Right. I did that. I don't think that can work because in general you don't know what's at
Okay.
the end.
Well, so what
So
will it actually do? Show me what it actually does.
I think this might go horribly wrong. Um, right. It's just gone to the end. I think it should be an error actually. I think that should be an error.
But wait a sec. It went to the end, which isn't the right thing for it to do because it didn't. There isn't it. It's not
No,
the
no,
end.
sorry.
Isn't.
The take, I suspect that it just treated that as the number of things it's seen is greater than this length. So it just, which is why it failed. But I think that should be an error because it
I do
can't.
too. Yeah, I do
Yes,
too.
good. Right, fine. That should be an error.
They can't predict the future or something type
Can't
error.
predict the future. Yes. Can I show you some of the other ones?
Yes, please.
So I've made a bunch of these. Just I thought. So this is a range thing that's similar to like the range function. So I can, do this, and it supports the different versions of range.
I don't really
Take
Can
understand
the
why.
upper bound be infinity?
the upper bound. The upper bound it is not infinity at the moment, but I think it probably should be. That should be
Yes.
possible. Yeah.
Also, I'm not sure why you put range in quotes because these functions
Well,
are doing the same thing that they would do normally.
Right. So that's the thing that we discussed, Christopher, and we've thought.
I'm not sure whether that's the right.
Yeah,
What
I'm
the
not sure either. There is an alternative syntax for this as well. Why don't we look through a few more of these and then you can get the flavor of it. So this was range. We looked at take. This is select. You know, there's like a selection criteria. Um, you know,
I'm sorry, I don't understand this. If that list is something hugely long, so if I do a select, put a permutations in there instead of that list. Instead of the explicit list, put a permutations of range of 10.
right.
See
Well,
what
I
I'm saying?
can't do permutations. I have to do
Why?
incremental object
No,
of
no, I
perm.
understand. I understand. Incremental object permutations,
Increment. I can't type as fast as you. Object.
permutations
Right. Okay.
of range
Yeah.
of
Yeah. I mean, it's going to
uh,
do what's going to do what you want.
range of 10. Okay, now put now instead of even Q and at that end,
What do
put
you want?
what do we want? Signature. Is that right? Signature
I,
function. I forget whether it takes a list as its arguments.
right. It's going to
Look at
get. Is
look at
that
look
signature?
no. Just look at the usage for signature.
Signature.
Okay, all right. So say equals -1 ampersand of hash
This
equals
is going to
-1.
have to be a function now. Equals -1
Yep, ampersand.
ampersand. Right.
Okay, now.
Yeah. Okay.
Okay,
Right.
let's try it.
This is un.
Okay, now let's try next value. Okay, now do it again. And again. Okay, now type of that thing, type signature percent. Very cool.
Good. 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 Right. I was. Now I
That's, by
had.
the way, a decent example, and you should
Yeah, yeah,
use it as something.
that's that. Sure, I thought you'd come up with some decent. I just want to
All right,
show this. Right, I'm just going to compile this thing here. So this is the Fibonacci incremental function, but it's working with expression, so it's not going to range out of I mean, it'll go on to big numbers. So I can do. Let's have a look. Right, here we go. This is 20 even Fibonacci numbers. You probably know what these are, but
that's cool.
and this is
So how about we do this?
the first 100. Here we go. The first 100 even Fibonacci numbers. Look at that.
Yeah, okay, it's magnificent. I want you to try something different. Okay,
Fine.
so uh say this is going to be a thing, the same incremental function thing, but instead of a Fibonacci number, we're going to look for all numbers, and we're going to go through numbers looking for ones that are odd perfect numbers. Yeah, this is
Right. So
silly.
then we could do a range.
Yeah, we can do a range, and then what we want to do is we want to do a select on the range.
Right. Okay.
And we want to do it to infinity.
Right,
The
right,
range to
fine.
infinity.
It's not going to go to infinity yet, but we'll do this.
Well, I don't know why it's okay, whatever. Okay,
Right,
now
right. And then what's your
say
select function?
divisors, total of divisor sigma
Divisors sigma.
of, well, actually, you have to look up the documentation. Sorry. Divisor sigma, just look at the documentation of that. What did you do there?
You know, why doesn't this just give the thing when
What the hell happened there? Is that because of, what are you doing?
well, I'm trying to get the,
It must be something to do with the syntax error. Could you please report that? Could whoever's paying attention, Gonzalo, I think, is
Yeah,
the person.
yeah, I will do
Can you
it.
report that and give the video clip to the user
right,
assistance
there we
folk?
go.
Okay,
Yeah, I
hold on.
will forward to QA. No worries.
Okay.
Right, there we go.
Okay. Actually, it's more user assistance that this should go to. Okay,
Right.
hold on.
Divisor
Hold on. No,
sigma.
I got to read the documentation. I
Oh,
don't
sorry.
know.
You probably
So,
wrote it. So
I probably did, but it's
right,
still
right.
okay. 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 So it's divisor sigma of 1 comma n, 1 comma hash, 1 comma hash.
Comma hash.
Okay, just try divisor sigma of 10, 1 comma 10, just outside, just to see what it does.
Yeah, fine.
Okay. Minus, try that for 26.
Like that.
Yeah, now subtract 26 from that number. Wait a minute. Could you type perfect number of 2? Okay, sorry, try 28 and subtract 28. Okay.
Right.
All right. So now minus hash equals hash.
Sorry.
So that divisor sigma, in the divisor sigma in the test,
Yep. Yep.
outside of the divisor sigma function, say minus hash equals hash, ampersand.
Hang on, sorry, this isn't right.
Yes, it's right. It's right.
Divisor sigma, but that's like equals 2 hash.
Which is right. It's fine. Don't worry about it. It's right.
Okay, all right.
Okay.
Sure
Okay,
it is.
now, right. Now type next value. Now type it again. Now type it again.
Okay.
And again. Okay. This is exciting. Now, okay. So this is a typical example where a progress monitor would be lovely.
Right. Okay. Yeah.
Okay.
You can't possibly have I mean, you can't have a substantive progress monitor.
But it certainly can in its next, insofar as it is doing a next. Oh no.
Yeah, I mean, it can say just I'm waiting, but it has no idea how far it has to go.
No,
Yeah.
it doesn't. But I mean, it doesn't know what the fraction complete is, but it certainly could know that the range is selecting more stuff.
I mean, it can tell you how many it has tried, right?
That's right. That's my point. Okay, you can kill it at this point. Okay, now just type perfect number of 4. And 5. Sorry, 5. Okay, so it didn't manage to make it to that number. I thought it might do.
Right.
It'd be interesting to know how long it would take to get there. Because, I mean, honestly, I think if you just did the select, if you did 34 million, if you did just to see this, take that divisor sigma thing there.
Yeah.
Take that thing and just just make this not incremental, right? Just to take the whole test, Okay, now make the whole thing, just take the whole expression, including the incremental objects, everything,
Yep.
whole expression, right? Copy it down, replace
induce
that
select.
by just a regular select, and
Right.
replace the range by range of 34 million. Okay. Now,
Like that.
yeah, now run it.
Should I put a
No, just run it. Huh. Interesting. I don't know how fast divisor sigma is. I would have thought it was fairly fast. Yeah, just wondered. Well, let's keep it running just for a moment here. And okay, my next comment is, I'd really like to see tuples.
Yeah, fine. So I'd like to get buy-in for these things are quite easy to implement. So I've made a list of more things, and tuples is the first one. I mean, it's not that dissimilar to permutations. But if we have buy-in for this, I can start doing some cleanup.
So another question will be pattern matching things.
Well, so these are things that I thought about. So I thought cases and delete cases would make sense. Can I just go through the core ones? There's just a couple more I'd like to show just to have some discussion on. Right, map. So you asked.
Wait a minute. Hold on. Back up. Scroll up. Oh, it's still running. Okay. All right. Okay. I just was curious.
Oh, it's finished.
Much fun. What?
Hang on. What happened? It finished.
Yeah, finished. Okay. Where is it? Where's the result?
There we go. So it got there. I would imagine this would have got there as well. I mean, it's
how would they compare speed wise?
For doing this, they would have been similar, I think, because they're doing the
Are
same
they
work.
identical because they're doing exactly the same thing?
They're not well, they're doing the same thing, but in different ways. So, but they're pretty similar.
I mean, the main difference is that the second one always expands the whole input, and so you
Yeah,
end
this
up
this
with
is going
lots
to
of
use a
expressions.
god more memory because this actually did range of 34,000, whereas this didn't.
To be fair, it should be select first on the left or on the bottom.
Oh, right. Yeah. Well, yes.
What? Wait. Why? What?
Because the top one's only going to return the next, it's going to stop when it hits
I see.
33,500,000.
Well,
I mean,
yeah,
in this case, it's pretty close because it's 33 versus 34.
Yeah. Yeah. I mean, it's
So
such
he
a
set the
small
range
difference.
right on the second
That's
one.
not.
But
yeah,
yeah.
right.
Yeah,
right.
that's not going to be.
Okay, all
In
right.
terms of memory, this
let's-
is the problem, not anything else.
Okay.
But
Okay.
this will consume a ton more memory,
Of course it will. I
which
understand
this
that.
one will not.
I understand. I got
Just
it.
pointing
Okay.
that out.
Okay. All right.
Can we look at some of
Yeah,
these others?
Yeah, please
I
go
thought they
ahead.
were
Show more
interesting.
stuff.
Right, map. So this is, so you do the sequence over this and it applies the function to it and then passes it up. So this is like, bool like that, or all of these. This was one, yeah, I mean, so I had this, yeah, so it's
I mean,
just,
that only seems interesting if the second list in the map, in the incremental map, is itself an incremental.
yeah, well, it is here. So yes, that's right. Well, here's one. Let me show you fold list because I have an example like that. Okay, so this is fold list. So not fold, this is fold list. So it's yielding up the things here. So it yeah, I mean it's just incrementally and then it's going to finish. Okay, so this is just like accumulating. It's doing fold lists, but one at a time.
Could we try something here in that
Yeah,
range?
yeah, sure.
That 1, 2, 3, 4, 5. I mean, in principle, that could be range of infinity.
Yes,
It could be an
yeah.
incremental range of infinity.
It could be, yeah, absolutely, yes. Well, look, I mean, this could be, let me copy this. It could be, right. I mean, this is pretty close to infinity, but not exactly. We
10 to
get
the
rid
10.
of that
10 to the
to,
10.
well, 63.
Why are you doing that? 10 to the 10. Why?
Well,
Why does it make any difference?
because I'm just, this is the biggest number that it'll currently support.
No, wait a second. Wait a second.
I think right
wait a
now,
second, Tom.
right now I'm guessing it's using a compiler,
Yeah, but
machine
this
integer.
could be, yeah.
But you should automatically switch if that number was bigger than that or infinity.
I think it could do it could certainly do a lot better than that. But this is, let's do next value sorry.
Oh, OBJ.
Yeah.
10. Okay. Good. But I just want to be clear. This incremental object thing is for range. I mean, again, it knows how big the numbers will ever get. So
in this particular one, so sorry, I'm not sure what you mean. This particular one has a max, but in general, it doesn't know that.
Well, okay, fair enough. But I mean, what are you going to do if you put infinity there? You're going to do machine ints, or are you going to do arbitrary numbers?
It could. Oh, I mean, it could be. I think if you did infinity, it would be expers. So it would be, machine integer expressions.
Okay.
Not machine.
I mean, for many cases, 128-bit numbers would be sufficient, right?
Yeah. Well, it could do that.
Well, but okay. But so how are you going to specify that? So
Well,
in other words,
if you have a syntax for it, we could do
typed.
If
I think that will be a good thing to
it.
support. Yeah, I think that will be a good thing to support because I think this is, this
Interesting.
is an efficiency hack, right? And
yeah.
Okay. All right.
Could do that.
What would happen if you just typed range of type to, range of type to 10, comma, whatever it is? What does that do? 10, comma, integer 128.
Right. It will be unhappy.
Well, I'll be very unhappy if it has too
Well,
many
that's-
commas there.
Right, it's unhappy. I could do type hint. So that's happy. But that's how type hint works. This would have to be typed
Why would it not be type hint?
because type hint evaporates
I see, unless it's actually in a
That's-
compiler thing.
unless it's in a compiler thing. Yeah.
Okay. All right.
Can I just show you map?
Yes.
Right, map. Oh, fold list. Sorry, we were looking at fold list. Fold list is, I think, kind of interesting. So that's the accumulation. These, yeah, so I can add up Fibonacci numbers generated by the thing. This thing here is, I don't know if you can read this, but this is also generating a Fibonacci sequence.
Yeah, I can see that.
Oh, right. There we go. So I had fold list,
Yeah, I get it.
and then I'm pumping it into map, you see. And so I can get, this is getting Fibonacci numbers. So I think that's quite nice.
It is
I
nice.
thought.
Okay.
There we go, 100.
Now, instead of
Oh, that's
table of the first 10, could you do take of that thing, comma 10?
like this. No, that's not.
No, it
Take
doesn't
doesn't
make
take an
sense.
iterator, so no.
Yeah.
Oh no, sorry. What would this be? I think
No,
next
take of the S, comma 10.
right, but take doesn't take an iterator, so I don't think that makes sense.
I mean, in general, would it make sense for all of these functions to just work? So you could say map of f, comma object or take. So all
Well,
these functions would just work with a new data type.
But you will hit the problem of copying things which are stateful because take and map they are all return the copies. So I think that's the biggest issue, right?
Yeah, but they're different functions because map returns like a list. And I think it would be weird if map suddenly started returning something different. It seems like a different function.
Well, wait,
And
map returns something with the same head as the thing that you
that's
gave it.
yeah.
Scan could work, presumably, but yeah.
Scan could work. Yeah.
I mean, if you apply map to such an object, then the same head as output would be set
right.
that
Could
object,
be the
and
same
not a
thing.
list.
Could
Right?
be also an incremental object.
Right, but how do you solve the problem of immutability? Like if you exhaust it, what happens with the original one if you use map?
Yeah.
I mean, we have a solution for that, right? That's cloning on demand, right?
Yes, but sure. But my point is, it's not automatic. It requires certain extra machinery.
Yes, and I think the thing that's here is very much for these incremental functions that do this stateful thing.
I mean, in some sense, the lazy list approach that I was taking years ago was exactly to cover this difference, to create persistent list that you can traverse any number of times out of these iterators. That was pretty much the only difference from my approach to this one. Plus, I was also using chunking and vectorization, but other than that, that was the biggest
say the
reason.
first thing you said about the difference.
Okay, so first difference is that lazy list, for example, is an object that you can traverse many times. It doesn't have a state.
Yes.
It doesn't exhaust itself. And the second difference is that more technical, that I was using chunking to use vectorization that is in the language.
Yes. But this seems very different because this is, as you're saying, this is the base of all. If you use an incremental object. Yeah. Okay. Anyway, so reduce map list. What's that?
Oh, I think that actually doesn't make, I implemented it, but it's basically map. Like you do a fold list and then you do a map on the output. But I think this is as good. I think this is good enough.
is it supposed to be map reduce or is it something different?
No. This is doing the map after the reduce. Map reduce does the map first, and then
No,
it
I
does.
understand.
Yeah.
All right.
But I don't think it makes sense. And if there wasn't a thing, the name, it could be like fold list map. But I don't think it makes.
It makes much sense.
I think it
All
doesn't
right.
make
What's
sense.
alternatives? What's under
Right. So alternatives. This is just something that we discussed. So we've got this sort of headdress idea. I mean, we could have something like create incremental object, just as a different.
Oh yeah. So what about the possibility? I mean, if we're really using system functions of just having an incremental headdress, not incremental object, but just incremental, and then just writing out things like incremental of permutations.
So I think we discussed this last time, and I don't remember why, but I think that we ended up settling more on the strings. I think part of the reason was that the usages might be slightly different. Like if you support it with just a pure headdress like this, you might assume that the behavior of the incremental permutations is absolutely identical and it supports all the same stuff as the incremental version, or as the non-incremental version, but that might not be the case.
Yeah, but I mean, still it would get rid of these ugly strings.
Right. Well, I guess the other thing is that we can always go back. If we do the string one, we can always later start supporting symbols.
Right, but the ones that you are supporting so far, I mean, we could support both strings and symbols, and the ones that you're supporting so far all do seem to have identical functionality, don't they?
Well, I mean, there are subtle differences. For example, range. I mean, the default upper bound of incremental range might well be infinity.
Sure, but it's not doing anything different between. Well, okay.
Right. I mean, there might be some. I could imagine there'd be some, like, I don't know, cases where maybe you can get cases to work with like you might imagine that there's
just
some
selective match queue, really. So yeah, I mean,
okay. Let's look at more incremental objects, please.
Right. So this is just some things I thought about of things to add.
Could you go to the root guide page, please, under lists? Core language lists.
Right. I spent some time looking at this.
Okay. Well, let's look at constructing lists, please. That first section. Okay. Okay. Isn't array relevant?
Could be, yeah.
I mean, array is relevant because you can give a small specification like array of f comma 10 million or 10 to the 10.
Right.
I think array is relevant.
Right. Now, what I'm not so sure about is like multidimensional things. So
yeah, well, that's an interesting issue because I mean that's the what's the analog of next value? This is where primitive recursion isn't so primitive anymore. I mean, in other words, it's not you don't have the same. There is a sense in which there's something fundamentally different between just doing things sequentially like successive integers and doing something different.
Yeah.
And that's, by the way, another reason why there might be differences in what these functions do, maybe. See, here's the thing. I mean, I could certainly imagine that the flatten of an array is, you could incrementally generate elements from the flatten of an array. See what I'm saying?
Well, yeah, but I don't understand what the input to the flatten, the source for the flatten would be.
No, I mean, if there was a function called flattened array or something that had the array, but it had it flattened, then that would be, you get what I'm saying? But we don't have that as such.
Oh yeah, sorry, I get that. Yeah, we don't have that.
Right. Okay, but anyway, array is one that seems like it would be worthwhile.
One-dimensional array could be.
Yeah. Okay, can we go back to the guide page, please?
Yeah, sure.
Is sparse array relevant?
I don't think so.
Why not? Let me give you an example. Sparse array, 1 arrow 7, 10 to the 10 arrow 14.
So what's that? Sparse array. So what was the
List 1 arrow 1 or 1 arrow 1 in the list, please.
Yeah. Okay.
Comma 10 to the 10 arrow 7.
So what would the iteration over that be? Just the elements that are present or everything?
No, it would iterate over everything. It would be a bunch of zeros. It'd be a 1 and then a huge number of zeros.
Fine. Okay. Sure. Well, that could be a source in
Yes,
all of
right.
these. Right. Hang on, I'm just taking some notes. Yeah, fine. Well, that's pretty easy.
Okay, let's keep going on that page, please.
Right. I mean, obviously it could do it like incrementally, like not. Yeah. Doing the whole thing.
Groupings is another one that's good.
Groupings.
Would be really worthwhile.
Well, I'll just add it to.
No, it goes on the combinatorial thing. It goes under sub tuple.
Yeah, sorry, right.
And so on.
Yep.
Okay. Now, groupings has slightly complicated argument structure.
Right.
Okay. Do you have groupings on the compiler?
No, but this would be an interesting way to think about it.
Okay. So there's no point in the random things because they're in a sense well, there is and there isn't a point. Here's the point. Point would be to maintain a single stream of seeded random numbers.
Yes. No, but I think that is useful.
I think it's useful too.
Yeah.
Yeah.
Well, I don't know where to put it.
Well, I don't either. So,
but I'll put it there.
We're recording this, so you don't really need to take.
I like to make notes. Sorry.
Okay. All right. Okay. Outer.
Well, outer. Yes, I'm still debating outer.
Sure.
I'm not sure. It's also a bit like map thread in a way, because you're taking two sources and then combining them with a,
yes.
You're taking multiple sources.
Map thread is not an obvious one to me. Okay, let's keep going. I said it's map thread is not an. Sorry. Outer
is not. Yeah.
Right. One. Okay, can you go back to the page, please? Go back to the other page.
I'm just putting question mark. Right. Fine.
Am I being confused? But isn't nest while list a very useful one? Or nest
yes,
while?
I put nest list, but I think nest. Yeah, absolutely, yes.
Okay. Go back to the other page.
Which other page?
No, the one that you're looking at there.
I'm looking at lots of pages. This
guide
one
page, please.
This is the guide page. Constructing lists.
Integer digits might be useful.
Sure.
Of a big number. Maybe not.
Especially an irrational number, right? Or real digits of an irrational number.
Yeah, I'm not sure how that works, so I don't know.
Okay, what happens with incremental of reading a file?
Well,
I mean, read list could work, right?
I mean, many of these things do have, you can read one thing at a time. So
right, yeah,
that's it's a bit ugly, and our things, yeah, yeah. I mean, file IO is definitely a possible thing. Yes, I'd rather have more core, new things to read better and do memory map, all sorts of things that.
Well, I think that the obvious thing would be just gulp a file, and then this is the incremental version of gulping a file. It would be a useful thing to talk to Piotr about.
Yeah, I think
what.
Yeah,
I mean, one question is what function. I mean, right now there's read list, etc., which already are incremental. What function that currently is not incremental could have an incremental version for reading a file?
get.
Import
Get.
or
Well,
import.
import is also
Well-
incremental, isn't it? Can't it be?
No.
But get
I
is
don't think so, but well, no, I mean, okay, so get only works on WL files, doesn't it?
sure, but it could read the expressions incrementally. But sure, yes, fine.
Yeah, and then also get has weird like evaluation semantics, right?
Yeah.
But
I mean, more
then
interesting is
that
some,
import is way too general. I mean, there's some
right, fair enough.
there might be
Right.
some importers that are possible to incrementalize and others that totally aren't, either for fundamental reasons, like I don't know, you're importing a graph and it's like it's not clear what it means to iterate over that, and others because we're calling some library that doesn't allow for incremental stuff. But I guess the question is like what I mean, we could invent a function, that only exists inside of incremental object or something, at least initially, that, reads a file. I mean, yeah, I don't know. I don't know.
Maybe
I
read
think
byte,
some of these binary reading bytes and things
yeah,
could be.
read byte array. could
Yeah.
be-
But all these like binary read list here, like that's a function that's already incremental.
Yeah.
Right.
All right,
Right.
let's go back to the main guide page, please.
This
No,
one.
Well, that one there, but now go back up from that, please.
This one, list manipulation.
I'm thinking about some of these things that. All right, scroll down a bit. Does any true, is that, wait a minute, let me think about that for a second. Any true could be applied to an incremental thing, right?
Yes, but it consumes the whole thing, right?
No, it doesn't, okay, because it's any. As soon as anything is true, it's a winner.
Yeah, but still, I mean, conceptually, it returns a single result there.
Yeah, it's what do you call it? It takes many down to one, so that's not
Fair enough.
not really a candidate for. What do you
I mean,
call that?
select is more like selector cases is more like the.
Yeah.
I think it's terminal
Empathy.
versus non-terminal. This is the
Okay.
terminology.
No, there's a category theory name for these things, but anyway.
Yes. The contractive mappings.
So yeah. More.
For what it's worth, split and transpose were good challenges when I was implementing lazy lists. They're kind of tricky to do.
Mhm.
Split because you basically return a bunch of these incremental things as a result.
I see.
In general.
You break one incremental into many incrementals.
Yeah. And transpose because you basically get a bunch of streams and return some transpose
So
stream.
wouldn't split just return the sequences of equal things? I already put it there. I mean, that's what split would do. So split of this would yield up this list, and then it would yield that list, and then this
Yes,
one.
but you don't know the length of that. And in general, that might be
But you keep
huge.
but it's just like select. I mean, I could write it now with a data structure. I mean, and map. I mean, it's pretty easy.
Yeah, I mean, the question was, at least for me, the question was what to return. Should you return a bunch of lists or should you return a bunch of
I think
like
it would
objects?
yield. No, I think it would yield this.
Right, but what if your the fragments in which you split things, if they are huge, it would probably make sense to return them also as incremental things.
Well, then there's another function, isn't it, that returns the thing and its count or something. Isn't there? Don't we have a function like
No.
that?
I mean,
maybe we should.
Not as such. I mean, but no. I mean, I've done it a million times.
Do we really not have a thing that's like 3 arrow A and
Yeah, counts.
Yeah, counts.
We have counts.
counts? But does counts return?
Counts returns an association. Okay,
Right,
let's go back to the main page. We're going to wrap up soon, but let's go back to the main page.
Counts as
Sorry,
yeah,
no, let's
sorry.
go back to the root
Yeah,
guide
I'm-
page, but for
Right.
root guide page, core language. Okay.
I mean, this is quite a lot of things. So version 15 is not a million miles away. So
I understand. So there's
Yeah.
a bunch of things there that are. I'm trying to think about other things like tuples, which are generators of very big exponentially big
Yes.
objects.
Well, combinatorial. Is there a combinatorial?
Yeah, go to higher mathematical computation.
Oops. Where the hell's that?
Next, top right-hand side of second row.
Right. There we go. Right. Okay. Combinatorial. Where?
Go to discrete math.
Presumably, if you just went to like permutations or groupings or something, it should be a related guide page.
Right, but what about things you can generate from a graph? Like, for example, yeah, there are a lot of things like find paths, where it'd be lovely to be able to do that incrementally. So, is it find path?
Yeah, that's not a bad one.
No, it's just called find path.
Yeah, fine. Okay.
And the point is that, there can be a very, very, very large number of paths. I think find cycle has the same feature.
Sure.
Okay, looking back at that graph theory page again.
This discrete math or
No, this page is fine. But now, I mean, there are tons of these where a find satisfiability instance is another one. You scroll down to Boolean computation. I don't know whether there's easy incremental versions of these.
yeah, I don't know either.
Well, I mean, it's find satisfiability instance is the name. Oh, I'm sorry. Find satisfiability instances. Sorry, satisfiability instances.
Sorry, where's that? I'm getting tired. Satisfiability.
Instances.
Right.
Okay, so that's a thing where you can count the number of instances you're going to get, but you could keep going and you could generate many, many, many instances.
Right.
Yeah, that's a good one.
Okay, I don't really understand that, but
Well,
it's the sat solver function.
Sorry, I'm not familiar with the algorithms. I understand what the and
they can do. I think they can do incremental stuff. In fact, I think yeah. The interfaces I've seen to sat solvers in other languages usually let you ask for like the next next solution.
There's some sort of iterative.
Yeah.
Okay. So like eigenvalues is another place where you can get the big one and then you get the next ones. I'm not sure how systematic that is.
Yeah,
that may be very hard.
I'm not sure that's so useful. I mean, you get this Arnoldi iteration that gets the biggest one, and then you can rearrange your matrix and get the next one. But
yeah. Okay, could you back up?
Yep.
Okay, let's just look at this for a second. Could you back up again?
I think I came from this one.
I think there are ones with spanning trees, maybe. I'm not sure about that, whether that's a place where you need multiple things. Could you click on trees and expression enumeration there? Why isn't that?
There's no page. It's not a clicky thing.
That's really weird. Okay. I'm trying to think about other places where I think I mean, Roman had mentioned successive digits in a real number, but that's, I think, rather exotic. I think the most interesting ones are these combinatorial ones.
Yeah, because they avoid creating huge amount of data.
Sure.
Right? Now, I mean, I have one technical question about cloning and constructors. Given an incremental object, is there a way to obtain the arguments of a constructor that you could use to create a clone?
Yes, that's what the full form does.
Oh,
Well, but how do you actually make a clone?
Well, this is going to be a clone. This one here is a
The identity object is a clone.
But
no,
like if you
sorry. You get the input form. I mean, we could. Oh, hang on. Let's come and do.
but like if you had, I get that you could type out the input form again.
Yeah, but
Right,
like
but we
if
could have a
you-
clone. We could have a clone operation if you wanted.
I think that would be useful.
Actually, a clone operation is pretty useful in general, for mutable things. So that's entirely feasible.
Should it be called clone or copy? I mean, I get that
Probably
often there's a
copy.
distinction made, but I don't know what we usually call it.
I think it's
We
copy.
never had either of these
the
concepts.
reason I asked for a separate constructor arguments followed by invoking that constructor is that would allow you to serialize it before cloning it. And so, for example, you could send it to parallel subkernels and stuff like that.
Well, this has a full form, so yeah, you could do that.
And when you move along it, the position changes in the full form.
See?
So I don't know what you mean.
If I
No,
if
you
you
have-
say next value,
If you crank it, then yes, and then
if you
ask for the full
say
form again.
ds equals whatever, ds equals that identity object. Okay.
That one there.
Right, now
Yep.
hit that. Now say next value of ds.
Yep.
No,
Okay,
full
now
form.
say ds, full input form.
There we go. Right. So it's.
Yeah.
Oh, okay. Yes, that's the right thing.
Why is that not an association? That second argument there. Surely it should be.
Well, it could be. I
I
mean,
think it should be.
I think I yeah, I think
I
that's
think it should be.
maybe. Anyway, yes, fine.
Now, if you do this for something complicated like permutations, would it
You'll see
still
more gobbledygook.
would it still record the position so that when you
Yeah.
refresh it
would
would have
behave,
to,
it would behave in an equivalent way. Yes.
but then it would have to spend a lot of time getting back into.
No, I don't think
up to
so.
speed.
No,
Not
definitely
necessarily.
not. No, it
Now,
wouldn't.
Depends
No, I
on
mean,
whether
if you
exists an
have-
algorithm to cut. the
No,
time.
hang on. Sorry, I didn't do that because I was tired and I've been doing a billion things, but it's no more complicated than this. The stuff you see in here, there's a bit more stuff, but you just have a thing and you have an index that you have to save out and then you reconstitute it. Sorry.
Yeah, but I mean, if that index is large, like if you have a huge permutation and you've already run through a million things, and then you make a copy, the first time you ask for next value, would it then faithfully rerun?
Sorry, no, that's not true.
How
not
does
true.
it know?
Well, I mean, the state isn't that big. I mean, it
Well-
just knows what the state is. And you just serialize that state. It's not very big.
How would that work for example, for a random number generator? Would we?
Well, a random number generator, it would not work for because
we could
maybe
make it.
could.
We could
Yeah.
use a skip ahead generator, which would
Yeah,
allow you.
fine. I mean, maybe, but
Yeah,
for
so-
permutations, this is trivial. This is trivial. Sorry, it is.
Okay, I have only one question. Should this be called incremental or incremental object? Because it's not really that much of an object.
Well, but
Well,
it's
this is-
mutable.
It is very much an object, right?
Yeah,
mean,
I
I
it
think
is.
we want to keep the
All right,
term
okay,
incremental
okay,
for
all right.
future addresses.
Yeah, maybe.
fine.
Yeah, I think that's.
Yeah.
So is this?
I like next value, but now what about? I mean, this concept of a function clone. Where else would we use clone? Are there other things which are mutable objects?
Well, data structures have the same. They have copy methods. They have copy operations.
But we could have a function clone that is just a top level function.
Well, we have delete object. We
Well, it
could
could have clone object.
copy
object.
object.
I think copy object will introduce so much confusion
yeah,
because
maybe.
99% of expressions do not need to be copied like that.
Yeah, that's. I think that's.
Well, but objects typically do need it, right?
Right, but I think clone object is more obscure. And I don't think people would think they have
Clone
to
object
clone
makes a
it.
promise though that it might not be able to keep, which is, I mean, generally if people make a distinction between copying and cloning is a deep copy. And I can imagine that we might have copies that are not deep copies.
That's all a good point. This would only copy, I think this should only copy up to incrementals that are in the thing, in the chain.
I mean, how would you do a copy? I don't understand. How would you do it otherwise? You would
Well,
make
the
the
copies,
input.
look, here's the copy. I mean, this is, you create the full form, you serialize and unserialize.
Well, I know. How do you do that?
Voila.
How do you serialize it with input form?
Well, there's a mechanism that I've built so that
I mean, it
How-
can't be
what
like
would you
two.
type in?
I mean, here's a terrible way, but
Yeah,
this
two
is
expression
can't
of
be the
two
solution.
string.
Yeah,
Yeah.
right. It better not.
No.
That's not a good way.
Sorry, this input form, it creates, there's an expression
We
form
know
here.
if you've got it in input form, we know that it's clonable, right? The question
Yes.
is, you should be able to clone it without going to input
Yes,
form.
yes, that's what something like this does. It can be copy, it could be a copy object. I don't mind, but it would unleash this mechanism. There's a mechanism for this.
Okay, but I mean, how many sub-values are you proposing to have for these things? Because
I haven't added information, but not many.
I really favor having a function. I like this next value function. I think that makes it, if that next value function was some kind of weird sub-value, it would be much less attractive
To you.
to everybody, in my view. Okay.
But look, I've implemented it. It is just calling,
Right.
the next.
But so should we have a thing that's called copy object or clone object, copy object? I mean, it's a little bit weird that
It's like
incremental.
problem with all these things of what does it do with things that aren't, does it
Makes
fail?
an error message, generates an error message.
So if I do, you see, this seems a bit weird. If I do,
Well, just do next value of 3. Just type next value of 3.
right, well, I haven't really,
Just type next value of 3.
right, so what does it do? Right,
That's not
some
very
garbage. Oh, right, it's called, right, I have implemented this in a very trivial way. So it's just, it's pretty trivial. But should that be an error? Probably. Yeah,
Yes,
well,
absolutely, it should be an error.
right. And copy object of 3. So it
No,
should
if
be
it
an
doesn't
error.
need a copy, it could just return the original and say,
could just,
it doesn't have to tell you are stupid because you asked for a copy of it. Right?
Yeah, I think it
Next
would be very
value.
useful because if we have mutable objects, especially coming from the outside, not just from the kernel, then the implementers could just they could just throw an error or they could provide the copy implementation.
Right. Some things may not be copyable, though.
Exactly.
Yeah.
Like, for example, database
So
cursors.
delete object fails.
Right, but if you have two cursors looking at a database, presumably you can copy a cursor. Is that, I mean, if you have some, can you, or can you
It's a
copy
very
stream
tricky.
pointer?
It's a very tricky question, Stephen, because, for example, if you set the transaction isolation levels to a certain way, then what you access might not be the same thing as what you accessed a minute ago.
I get it. What about stream pointers for files? Can you have multiple stream pointers running around?
Implementation
Is horrendous.
Yeah, dependent.
All right, but I still think copy object is a worthwhile thing to have. Christopher, do you disagree with that?
Sorry, I missed that. What was that?
Do you disagree that copy object would be a worthwhile thing to have?
You had your chance.
I mean, I still think that it can lead to all kinds of confusion. And maybe we should actually see what would use it. I mean, maybe some stuff with external objects, though I'm not sure that we can, in general, copy a lot of external objects.
Yeah.
Yeah, there's a bunch of foreign function stuff which is not copyable in general.
Right, but if you say in some cases that it's not copyable by returning a failure or something, it will probably be still useful.
Yeah, I think that will be useful.
I mean, it's just like delete object, right? I mean, if your objects are deletable or copyable, you make an up value for it, and otherwise it will just then say can't do it. So
right, what does copy object of 3 do? You see, this isn't so trivial.
I mean, I think the other thing is that delete object is more like, okay, general expressions you don't have to delete; they'll be freed on their own. I mean, but we have delete object because there are lots of expressions that very transparently point to kind of external things like files or cloud objects and stuff where no one thinks that when the expression expires, then that thing goes away. So the question is for copy object, similarly, would it point to things that are like obviously not normal expressions, where the thing you're copying is not the expression, it's like this external thing.
Right. Like if it has a handle to a car and you say copy object.
Right. You
Clearly
know that it's
doesn't
not
copy
just
the
copying
car.
the expression. It's gonna, yeah, right. Well, no. The point.
It's an error message in that case, I would think.
Well, no. Okay. In that case, that might be a very difficult case to do the. But
Well,
my
then
point
that's
is like
almost
if you have
an
a if you have
argument in favor of it being called clone, which is a slightly weirder name.
well, no, I think it's okay. I guess here's maybe the point is that with delete object, you don't run delete object on general. When you run delete object on an expression, there is no concept that you're deleting the expression, quote unquote. You're deleting whatever the expression is pointing to, and it's generally
Yes.
pointing to some external thing. With copy object, I'm saying that I think it would have to only work in cases where, similarly, the thing you're copying is not the expression, it's whatever thing the expression is pointing to.
Christopher, but on by default, all expressions, normal expressions in Wolfram language are immutable, so you can just return them because they are by default copied.
No, exactly. I mean, and just like deletable, expressions are normally memory managed automatically, so you don't have to delete them. The point
Right,
is that
but
the only reason you need these functions is to deal with things that are not expressions, but which are referred to by expressions.
right. But my point is that for copy object, it's easier because for delete object, it's not clear what to do when you
Yeah,
feed
but
into
it's
normal
not so
expression.
trivial, Leonid. Or you can take over, designing what the list of things, because like is it an expression? Is it a file handle?
Well,
It's not so easy.
But by the way, I mean, this is all partly an argument to say that the copy object of 3 should return an error, because the whole
Well,
point is that
right. That would
we're
be
not going
fine.
to copy. We're not copying expressions. We're copying whatever is pointed to
Yeah,
by the
yeah.
expression, and
So
3
I
doesn't
think it
point to
should say
anything.
something like copy object of 3 can't be done because 3 isn't doesn't provide a copy method or something.
We're just cannot
but what would
copy
be
object 3. Yeah.
but what would be wrong with just returning 3 in this case? Copy object of
Because you
3.
don't know can you come up with a decision procedure to decide whether it gives an error, whether it actually does something, or whether it, if you can describe that decision procedure, fine.
Well,
Yeah, I mean,
I have to run.
I challenge you, like
well,
with
maybe the decision
object.
procedure. I mean, the easy procedure is just if it has something defined, you do it. If it doesn't have anything defined, it just runs the identity. But I think that's
Yeah.
wrong, because I think that the whole point is that copy object is not for
I
copying
agree with
expressions.
Christopher.
It's for copying external objects that actually we're
I
copying them as
totally agree.
meaningful. And so if it just copies expressions too, I think it'll be super confusing, because people will
I
be
totally agree.
copying their
Totally
expressions
agree.
left, right, and center.
Yep.
All right. So basic conclusion for right now, no copy object function for now.
Fine. But let's have this, because I think that'll be useful.
I mean, by the way, I mean, if you just want, in the particular case of incremental object, so actually, wait, here's a question. I forget the answer, Tom. So if I make an incremental object, then I call incremental object on that incremental object to make a second level incremental object. If I increment the first level one, does it also increment the second level one, and vice versa?
So I'm not sure what you mean.
Like I'll give you an example. You have your fib.
Around
You have your fib comp. Yeah, this is where I'm going. If you have your fib comp, right, which is like your Fibonacci incremental
Well, that was
object,
an incremental
right?
function, not an incremental object. But I made an incremental. I mean, the incremental.
Okay, then do this. Do this. Just to make an incremental object that's like ranged to 1,000 or something.
Right.
And give that a name.
So like this.
Yeah, and give that a name. Like name it. Okay.
Right.
Now have ds2 equals incremental object of select of ds1 comma, I don't know, even q.
Right.
Okay, now the question is, if you run next value on ds2, will it affect DS1 or did it just
Yes,
copy DS1?
yes, it will. Yes.
Okay, will affect. Okay,
No, no,
so
wait a
then
minute. No, no. Do next
Oh,
value of
sorry, I
DS2.
did that the wrong way around. Sorry.
Next to
it's
value of
both ways
DS2.
work though, but yeah.
Yeah.
Okay, now say next value of DS.
Oh, you just reran it again though. Okay, yeah. It'll say 3, I guess.
Yeah,
Okay,
yeah.
yeah.
That's
All right.
then
So we're in very mutable land. Okay, fine. So I guess
these are mutable things.
yeah.
So yeah.
Yeah, right. Okay. If that wasn't the behavior, I would have suggested that identity would have just been effectively copying it, like the incremental object of identity, but I guess not.
Right.
All right, looks good. Anything else we should cover here?
So this is a green light. I'll go ahead and start flushing this in.
Please. Yes.
Great.
And particularly get things like tuples. That will be very useful.
Yeah, fine. That was the first one on the list. Right. Are we good to go?
Yep, I think so. Sounds
Yeah,
good.
interesting.
Okay,
Yeah,
good stuff. See you all later. Thanks.